We're good to go.
Hi, everyone. Welcome to today's webinar. I'm Grace Plummer. I'm the Managing Director of the Research Institute for Environment, Energy, and Economics at Appalachian State University. You can see a little bit about the Institute on the slide here. I'm kicking us off this afternoon only because we build today's webinar to the App State community as one of several that in a series that the Institute convenes each semester. I was connected with the High Tech Foundation several months ago about the Cloud Data Analytics Fellows Program that you'll hear more about today. And my colleague Lauren Essick, who's on this call as well, worked with Deidre and the High Tech Foundation team to schedule this webinar to share more about the program with our campus community. Since then, other connections have been made, and I understand that there are other regional universities represented on here today, Berea College and some others. Welcome from over the mountain. Congratulations on the momentum that you're building with this program, Jim and team. And I appreciate the opportunity to welcome the App State folks today. I look forward to learning more about NOAA's Open Data Dissemination Program. And for App State folks attending, Lauren and I are happy to serve as a conduit for opportunities and information that might follow today's session. And with that, I'll turn it over to Jim to proceed with today's program. Thank you.
Thank you, Grace, and thank you for your kind words. I'm Jim Estep. I'm the president and CEO of a group called the High Technology Foundation. We are focused on trying to help expand the knowledge sector in North Central West Virginia and to some extent Central Appalachia. And one of the focus areas that we've been spending a lot of energy on, it revolves around the operations of the National Oceanic and Atmospheric Administration that we have in Fairmont, West Virginia. NOAA has brought just several of their programs to our community. We have 3 of their satellite ground station programs. We have their one of their flagship supercomputing centers. And it's really had a wonderful economic impact. And it's really helped not only in economic diversification, but really helped in our efforts to try to, bring a little more balance to our region's workforce relative to educational attainment. So we're just so thankful to the investments that NOAA has made and they continue to make. One of the things that we've been really excited about is NOAA's work to try to make their data portfolio more accessible to, I guess you could say, society in general. And the reason they wanted to do that in large part, and you'll hear a lot more about this from Adrian in a few minutes, but the reason they wanted to do that in large part is because they're hoping to enlist, the entrepreneurial and innovative potential of society to help them, answer some of the resiliency and adaptation needs of climate change. And I don't have to tell anybody on this call that climate can have an impact. God bless you all who were impacted and just the things that have been occurring. It's insane, but it just puts a fine point on the fact that we really have to work hard on this. And one of the things that we hope to do at the High Tech Foundation is to not only do what we can to help NOAA achieve their goals, but we hope to maybe figure out a way to have an economic benefit on Central Appalachia as a result. If NOAA wants to tap the innovation and entrepreneurial potential of society, then let's try to build an entrepreneurial and innovation ecosystem in Central Appalachia that can help them do what they want to do. And so we created this program. We've got a little bit of funding from NOAA to try to get it off the ground. It's called the Ecosystem Project. And we hope that we can figure out ways to mobilize Central Appalachia to become that ecosystem of innovation entrepreneurship that can help NOAA and at the same time create an industry in our region that can have powerful economic benefit, a real win-win. And of course, we couldn't even begin to go down this path if it weren't for, number one, the enormous investments that NOAA has made not only in Fairmont, West Virginia, but also in Nashville, North Carolina. Those 2 investments have really given us strategic positioning. But the one thing that's really enabling this whole thing to be a potential is NOAA's efforts to leverage cloud computing technologies and advanced data science technologies to make their data available and to provide the tools needed for this kind of ecosystem type activity to take place. And that has catalyzed within NOAA as the NOAA Open Data Dissemination Program, and which you're going to hear a lot more about. But that program is making just enormous strides, doing amazing work, and making this data not only available, but also available in a way that can empower entrepreneurs. So, of course, if you think about us wanting to build an ecosystem in North or in Central Appalachia, what is one of the most important ingredients of that ecosystem? Well, it's the innovators, the entrepreneurs. And if you think about where is the most fertile ground of potential entrepreneurs and innovators in Central Appalachia, it's clearly in the student body populations of all the colleges and universities in our region. And so we created this program as part of the ecosystem project called the Cloud Data Analytics Fellows Program. And the whole idea behind the program is to institute in these institutions activities that will, number one, expose the student body population to this opportunity, to the fact that there's NOAA data out there that has not only a practical, innovative potential, but also has an entrepreneurial potential. And then to work with those institutions to really put some structure around it so that at the very least, we're exposing the students to the effects of climate change and how it's going to impact them no matter what their career is, no matter what company they work for, they're going to be exposed to this. So we're creating a value add there. But we also hope that some of them get some interesting ideas for innovation or startup or whatever, so that they can become, the leaders of this ecosystem that we want to grow over time. So we started this fellows program in a collaboration with West Virginia University about a year and a half ago. We've been piloting it with them. It's had great success. They're really embracing it. And, we want to expand this to other colleges and universities. And I want to applaud, Appalachia State, RIEEE, and some of the other schools who've stepped up to say, we want to be a part of this. And so we're just so thrilled and so excited to work with you guys. We want to help you every way we can. We're talking with NOAA, but we're also talking with the Appalachian Regional Commission about making money available through ARC so that colleges and universities can fund these fellows programs at their institutions and just go. And we hope also that the various schools come together in kind of a collaboration, a consortium, if you will, to help each other. So we're really excited about it. We're thrilled that you all are interested in doing this, and we hope that we can really move out on this and do some great things. So thank you all for participating today. I would like to, at this point, it's my great honor to introduce our next speaker, Adrienne Simonson. Adrienne is just an incredible woman, a dynamo, amazing leader. I can't say enough about her, but what she's done with NOAA's Open Data Dissemination Program is nothing short of amazing. And as I've mentioned earlier, it's really the catalyst for this enormous opportunity for all of us. And so without further ado, Adrienne, I'd like to pass it off to you.
Well, good afternoon. It's a pleasure to be here today. Thank you so much for that invitation and the introduction, Jim. That's really very sweet. The NODD team has really enjoyed working with West Virginia University and the High Tech Foundation on the Cloud Data Analytics Fellows Program. We're excited by the possibility of other colleges and universities in Appalachia focusing on the development of these critical skills. NOAA Data in the Cloud is an excellent resource for faculty and students, as well as the available cloud training provided by our cloud partners. We look forward to your questions. First, let's get into the presentation. Next slide, please, Deirdre. Our agenda today. First, I'll briefly explore NODD's purpose and mission. Then Kate Zura, NODD Communications Lead, will review some of the available data and how to find it. Next, I'll discuss the benefits of cloud scalability, explain who is using NODD, and explore how we communicate with users. And then Jenny Disson, NODD's Engagement Lead, will walk us through a selection of relevant user case studies after which we'll answer your questions. Next slide, please. NODD began as a research project in 2015 in response to the exponential growth of NOAA data. NOAA wanted to improve users' experience as well by making the data easier to find and access. Today, NOAA Open Data Dissemination, or NODD, provides open data from each NOAA line office via 3 cloud service providers, or CSPs, Microsoft Azure, Amazon Web Services, and Google Cloud. By harnessing the scalability of the cloud, NODD provides end users with improved access for NOAA data and reduces their reliance on internal NOAA systems. There are no use restrictions. User registration is not required. Appropriate metadata is provided. Most significantly, there are no egress or data download costs for the users or for the agency. This is because NODD leverages the CSP's expertise, platforms, and tools via unique public-private partnerships that democratize NOAA data dissemination and allow for interoperability and innovation to solve societal challenges. Next slide, please, Deirdre. NODD works closely with each of the CSP public dataset programs to publicize the data availability to the end users and to ensure accurate information is provided on the dataset landing pages pictured on the slide. These dataset landing pages are a starting point for the user and often also include usage or code examples and a list of publications relating to the dataset. It also provides contact information for our team and in some cases the data point of contact. Links to the data on these public dataset programs are provided on the NODD website, noaa.gov/NODD/datasets. We'll make sure that you have the slides so you'll be able to reach anything we talk about afterwards. Next slide, please, Deidre. To give you an idea of how this works from an architectural perspective, the NODD pipelines begin with the data that originates in each of NOAA's line offices and resides on NOAA's on-premise systems. For those who may be unaware, there are 6 NOAA line offices, of which the National Weather Service is one. The data is either pushed by the NOAA line office or pulled by the NODD technical team to any or all of the 3 cloud service providers. We're actually moving to a push model, which may improve latency slightly on near real-time data. Users, like yourselves, can access the data through the links on our website, through the public data programs of each of the CSPs, or through their public data programs directly. Users can also register for data alerts and updates via SNS, PubSub, and Azure event notifications. Please refer to the CSP landing page to see if a data set of interest has an event-driven notification set up. Next slide, please. There are hundreds of NOAA datasets accessible via NODD from across the agency. I'll let you read the full list, but I want to highlight that it includes near real-time datasets that can support public user operations, including geostationary and low Earth orbit satellite data and products, plus a variety of weather models and forecasts from across NOAA. NODD often builds a full period of record for select data holdings based on CSP and data provider requests. NODD datasets are machine readable, and NODD is included as a data provider partner in the National Artificial Intelligence Research Pilot announced January 24th. I'll note that only a few NOAA datasets are ready to date, but they're available on NODD and more datasets are coming. And I was going to drop into the chat, actually, if I can. Yeah, the link to the National Artificial Intelligence Research Resource. A full list of NOAA data available is listed on the NODD website, which is noaa.gov/NODD, and that includes direct links to the dataset landing pages on each of the CSPs. There are 64.5 petabytes of data on NODD as of today, November 15th, 2024. At this point, Kate Zura will walk you through 4 relevant datasets as examples of what is available. Kate, the floor is yours. And Deidre, will you go forward one more slide? Thank you.
Thanks, Adrian. So as Adrian mentioned, I'll step through 4 datasets that are available. I'll step through them as examples of 4 datasets that are available through the program. And we've laid out these slides as a resource and a reading resource for later. So there's going to be a lot of information. I won't go through it in great detail here. Let's do it at a high level so that you can reference these later, but I'll orient to how we have each of the 4 slides set up, where each data set, the gray box, is going to contain key details about the data set. And then the blue boxes on the right are example use cases of how key industries are using them. And then to get to specific links related to these data sets, the links on the bottom of the page will link to the NOAA landing page so that you can go learn about the data sets directly from the NOAA pages. And they'll also link to the cloud service provider landing pages of the cloud service providers that are hosting this data set through the NODD program in collaboration with us. So to dive into an example, climate normals is one of the data sets that we have through the program. And this is a data set that provides long-term perspective on weather and climate conditions in the US, calculated for a 30-year period. It consists of annual, seasonal, monthly, daily, and hourly averages and statistics of temperature and precipitation in the US at 15,000 weather stations. It's used in industries such as energy forecasting, insurance companies, and agriculture. And these are some high-level examples of how the data is used. And then later on in the presentation, Jenny's going to dive into some examples where we've heard from users specifically how they're using the data. And those use cases are always exciting to learn about. And the links here, so Climate Normals, we have it available on Amazon Web Services and Microsoft Azure. And then the orange box also includes that top link to the NOAA landing page to learn more about it. And then that, Deidre, can we jump to the next slide, please? And I'll dive into the next data set. Thank you. So the next one is GHCN. It's available in monthly, daily time steps, and then it's also currently developed in hourly and soon to be available. But this data set is an integrated database of daily climate summaries from land service stations across the globe, and also, such as mentioning, the monthly and the hourly also available time steps. But GHCN contains records from more than 100,000 stations in 180 countries and territories. This is also examples of key industries where it's used in agriculture, health sciences, and climate science. And we have GHCN available on Amazon Web Services, Google, and Azure. So those are specific links where there's links to the daily and the monthly for those as well. And then we can dive into the next slide in the next data set, please. And then the next data set is the National Water Model. This is another example of a very popular data set available through the program. And this is a hydrological model that simulates the water cycle and stream flow over the contiguous United States, Hawaii, and Puerto Rico. It predicts water flows, water-related hazards such as floods. It's used by water managers, energy industry, and emergency and water quality services. And we have the links below for the NOAA page and all three cloud service providers as well, just to call each of those out. And then if we can jump to the next data set, please, as well. On the next slide. Thank you. And so GOES-R, this is one of our very popular satellite data sets. And GOES-R is one of the geostationary satellites, so it stays within the same position over the Earth and takes imagery. And this imagery is used in the aviation industry. It can be used for wildlife monitoring, wildfire monitoring, and renewable energy forecasting. And GOES, there's a series of satellites. So there's GOES 16, GOES 17, 18, and that just made me realize we need to update this slide because GOES 19 is coming soon. So when that's available, we'll update those links. But for now, you can look at the cloud service provider landing pages for those three satellites, and then GOES 19 will be coming soon in November. Well, later in November. So stay tuned for that new data. And then with that, I will pass it back over to Adrian. Thank you.
I'm a little slow with the controls. Thank you so much for that, Kate. I really appreciate it. And I'll just say that NODD is scalable by design and is not constrained by costs, since egress is free and there are no annual contract costs. As a result, NODD is orders of magnitude more resilient than our on-premise systems. The NODD team released a publication in September, this was a year ago, September, titled NOAA Open Data Dissemination, Petabyte Scale Earth System Data in the Cloud in Science Advances. This article dives into detailed usage metrics on one of our three cloud service providers, AWS, revealing wide use of NOAA data on the platform and highlighting the value of hosting NOAA's data on the cloud. NODD holdings on AWS-C sustained access of more than 5 petabytes of data per month and more than 1 billion interactions per week, with occasional sustained interactions of 1.5 billion per day. And nobody is impacted by that at all. other users are not impacted. You can explore this article in depth by clicking on the picture of the magazine. We will share the slides with you afterwards. In addition, as you can see via the bar chart, the percentage of accessions originating from AWS-owned IP addresses is trending upward over time. Heavy use of NOD holdings on AWS, 10 or 20 times greater than the baseline, is driven by on-cloud resources. This strongly suggests that the bulk of users are availing themselves of the tools provided by the CSP platforms rather than egressing the data, especially for large analyses not typically possible via traditional infrastructure. Next slide, please, Deirdre. NOD is more than a technology or a contract. NOD is an ecosystem. NOD provides timely and informative responses to user questions, as well as technical and scientific support, and loops in internal data owners and stakeholders, including CSPs, when appropriate. Remember, you can always reach out to nod@noaa.gov with any question. The CSPs are also interested in understanding their user community's needs and collaborate with NOD to provide technical as well as communication and engagement tools to reach users, inform them that data is available, and answer their questions. They also provide cloud training on their platforms. In the graph on the right, the NOAA logo represents the LOs and their data. NOD, the cloud service providers, other partners, and public users work with NOAA to ensure the data is accessible and performant. It really helps when users let us know if they are experiencing challenges. NOD is continuously looking for ways to connect with our users in order to understand their experience and improve it. Engagement is key to understanding their use cases. So NOD's targeted engagement activities focus on prompting users to reach out, including a relatively new concept called office hours we'll explore in a minute. First, let's talk about who is using NOD. Next slide, please, Deidre. NOD doesn't require users to register. Let me repeat that. NOD does not require users to register or to be authenticated to access the data on the cloud. So we only know who the end users are if they tell us, and that's usually because they have a question and have emailed us. NOD is the delivery vehicle, if you will, for NOAA line office data, so our most important users are internal. Some of those internal scientists and staff find unique ways to utilize the simplicity of accessing authoritative NOAA data via NOD for their own programs, as do a variety of federal agencies. Also note that all of our CSPs have internal teams that utilize the data on NOD, such as Google GraphCast or Aurora, which is Microsoft's AI that is a foundation model for the atmosphere and is reportedly first to predict air pollution of the whole world. But end users come from a variety of sectors and data experience levels. The sectors range from public and private multinational to small end industry users to intermediary software product or services solution providers, as well as students at university and graduate levels. NOD routinely responds to emails from highly skilled cloud analysts who reach out with nuanced data access questions, or from users who are just beginning to work with either the data itself or the cloud as a new access option. Your question to nod@noaa.gov will be routed appropriately regardless of your question, whether it's a science, dataset, or cloud concern. We connect users with the right subject matter expert. Next slide, please. So if we don't know who users are, how do we support their use of NOAA data? How do we help users and potential users to learn more about using NOAA data in the cloud? NOD needed a targeted way to understand users' experiences so we could continue to improve them. NOD engagement lead, Jenny Disson, developed the office hours concept in order to connect with users and give them an opportunity to ask questions and listen while other users ask their questions of the dataset subject matter expert, the CSP or NOD, in a relaxed environment. Each virtual session is an hour and 15 minutes long, focused on a specific data set, and co-hosted with the relevant NOAA line office and one of our 3 cloud service provider partners. Our 2 most recent office hours, both on joint polar satellite system products, were held on April 18th with Google Cloud and June 13th with AWS. Visit our website at noaa.gov/nod to view materials from past office hours, including slide deck presentations, user questions, and subject matter expert answers, and other resources, including recordings. We didn't start out recording these, but we got there pretty quickly. You can also view upcoming office hours and register for them from noaa.gov/nod. Registration is required for office hours for invitational purposes only. The data itself continues to be accessible without registration. Whenever you have a question, email us at nod@noaa.gov. And now I'm going to turn over control to Jenny herself so she can walk us through a few very valuable use cases. Jenny?
Thank you, Adrian. Okay, so we've heard a lot about NOAA data via the cloud. There's a lot of NOAA data, and there's a lot of sectors of the US economy that have started to really use, apply, access, and make change in their decision processes. So I'm going to cover 4 case studies across 4 different economic sectors. Here you see a case study by HNTB. HNTB is a global civil engineering company. HNTB reached out to NODD because they were heavily concerned about bridge failure due to extreme precipitation. When they had several questions regarding NOAA data, MRMS specifically, this is a data set that provides rainfall accumulation on an hourly basis for the United States. HNTB was challenged with understanding where can they help their customers prioritize which bridges to repair. It began as simple as, which ones are most vulnerable, which ones do we repair, how can we quickly analyze all the infrastructure in the United States. So this meant looking at a lot of rainfall data, a lot of records, and a lot of bridges. How can you quickly analyze this using cloud? And that's how the journey started. So they, again, referenced accessing MRMS data, multi-radar, multi-sensor, via AWS. And I'd like to talk about the impact that it's provided for them. Now, Eric Zucker, who is a structural engineer from HNTB, has since, over time, become very integrally involved with NOAA as a practitioner because of how much this cloud access is game-changing the way civil engineers look at problem statements. It's also highlighting the fact that civil engineers who are required by law and license to follow a certain code have a need to do scenario analyses. So this is what cloud capabilities are providing for this particular group that has to look at different scenarios. So I want to just take a minute to read the quote from Eric. Cloud access has improved the ability for access. Let me try again. Cloud access has improved the ability to access this data and the efficiency at which it can be used to assess risk and critical infrastructure. Quantifying the impacts of extreme rainfall enables a variety of stakeholders to create and implement targeted strategies for communities to effectively prepare, adapt, and respond. Eric, during Helene, also used the same capability and submitted bridge failure down the street from my home here in Asheville, and was able to quickly tell me on the Sunday of Helene how bad it was going to be and that the bridge was going to fail. This is just one example. Next. Kate talked about several data sets that are used by the energy industry. Here we share a startup, Circle Solutions, that was acquired by Enverus. Enverus is a software solution provider company. They basically focus on the energy industry and renewable energy industry sectors. When you think about the integration of wind and temperature and how utilities need to better understand and forecast solar and wind so they can integrate with existing and traditional energy sources, the reliability and predictability matters. So what's happened is with wind, when you use a NOAA data set called High Resolution Rapid Refresh, HER, as we like to affectionately call it, her data is heavily used by the energy industry and others, not just energy. But this particular company, an example, has built an AI method and model that integrates her data, reconcile historical wind with near real-time wind, and create a model that can be used by energy industry to not only forecast wind, but also forecast solar. This allows energy producers and wind farm owners to know when to shut down, when to ramp up, because that takes a lot of time. And so those that are participating in wholesale markets or energy trading, every second counts in understanding what energy demand is for the next 24 hours and the next hour, and what is the supply of that source. So this is a great case study, and we've been following them for quite some time. They're also very reachable, and it's a great case study that we like to talk about. Next. Okay. M3 Works is also one of our beloved case studies. They are a small startup based in Idaho, and they've been primarily working, again, looking at her data via AWS and Google, and they generate their own high-resolution wind model. This is being used to understand when does snowpack melt, what is the snowpack model, and they created their own called iSnowball. So this is, again, solution providers that are using NOAA data to create their own value-added product and working directly with city planners, the state of California in this case, to understand water resources issues. Now, those of us that are dealing with Helene understand water resources means too much, not enough, too much too soon, and not enough is equivalent of drought. So for this particular case study, M3 Works generates their own products and estimates water resources in the California market and other parts and determines snow forecast. This snow forecast is so critical to understanding wildfire prediction, vulnerability, and also availability of water for energy generation. And the capability that they're able to produce this model and this particular tool is because her is used in the cloud and accessed both via AWS and GCP. Right, one more case study. All right, so it's not all startups, although we like to talk a lot about how solution providers, whether it's public or private or nonprofit, are creating solutions that meet our socioeconomic need. This particular case study talks about our GO16 data. So Kate talked about our geostationary satellites. We have 3 types of satellites: geostationary, low Earth orbit, and what we call the sun satellite. So there's one pointed directly at the sun. The GO16 satellite is used for many, many things. But in this case study, we talk about how GO16 measures through its sensor called the Advanced Baseline Imager. So this is imagery that captures high resolution infrared and visible data. It talks about how it can detect methane and how methane specifically absorbs infrared radiation in these specific bands that the satellite makes accessible. So scientists can detect emissions coming from specific places, and they can detect signatures under clear sky conditions. So the GO16 stationary data is located in one spot in space. It doesn't move like our LEO satellite. LEO goes around the Earth, goes as fixed. And because it's fixed, we can track and understand the locations where you have methane plumes emerging on a consistent basis. So Kate here has done some research and found that this has been particularly helpful, and it points exactly what are the point sources of methane in the United States or where GO satellite looks and points. We'll put a link to this particular paper. And so it's, access via cloud. So GO16 data is a lot of satellite data, and it's near real time. And you want to monitor and measure the sort of plume observations on a near real time and where is the plume moving. So the near real time to GO16 is complicated, and the access via AWS is what makes this particular use case interesting because it's supporting science and research. So with that, I will stop here and just, open the opportunity for conversation on use cases. I'm sure there are slides after me, though.
Actually, this is our last slide. I'm fairly certain. So it's a good opportunity to turn over to questions. I will take. I'm sorry, I hear someone.
Shashir has a question, I think. You want to go ahead, Shashir? Hopefully I'm pronouncing that correctly.
I'm not sure that they're able to
Unmute.
talk on the mic. I think it's just the writing. So
Try
there's
now.
a question.
Try now, Shashir. See if you can do it. Shashir?
No.
You unmute. I think you can talk. Oh, okay. He's unmuting.
Oh yeah, I got
don't-
it. Yeah.
Yeah, you got it. Okay.
Oh, hey there, this is Shishir. I'm a assistant professor of economics here in App State, and I'm so glad that WVU is doing a lot of work. WVU is my alma mater. West Virginia is home, so
Oh,
I'm so
nice.
glad that you guys are doing a lot of good things there as well. I was wondering, like, I mostly work on health space, and I'm interested on like how this health and climate, these are related on it. So is is there a way that I can find some of the paper and a creative way of people using this data and like writing research papers? So that's one part in academic space. The other space I want to explore is what are the entrepreneurial domain, how people have been using this particular data set for some sort of entrepreneurial and innovative, endeavor.
I can take that for a second and probably jump in. Others are welcome to jump in. So your first question is on the use of NOAA data and what others are doing for health and epidemiology studies, for example. So just at a brief high level, and we can probably follow up, there's air quality data to understand impact of pollutants and how they move across different locations, the impact of air pollution on human health. That air quality data measures is dependent on temperature, humidity, heat data, by the way. So tracking heat waves and their implications for health-related indices is another. Weather and climate data and extreme weather is another because of vector-borne diseases and the seasonal patterns, for example. A lot of people are studying impact to allergies, and solution providers have actually started to build the connection between NOAA weather climate data and what that's doing to allergy patterns. There's also the correlation between public health and what we just have experienced with Helene and the impact to water resources, the most recent one being lead in our water content. So drawing these connections and correlations, there's a lot being done on climate and health. And I'm going to put here in the link NIH HIS, which is a great place to start. Heat.gov is another. These are starting locations where you can understand what NOAA and its partners are doing to advance health-related topics. Several specific research topics like comorbidity associated with extreme heat and health, or human health, or health and pregnancies. App State has been working with my colleague at NCICS. Her name is Dr. Jen Runkle, and they have been publishing papers like wildfire, literally. And there's a lot of work going on there. So Jen and her team are looking at data set called Incline Grid and others via the cloud to quickly process for a specific use case on human health. Mental health is a big topic. So it's a question of, what space within health is of interest. And I think you had a second part to the question.
Can I add a little bit on it?
Sure.
So some of the research paper I'm currently doing, and Jen Runkel is one of my co-authors, where we look into maternal health and stuff. We are not using this data set for that though. But one of the work that I recently do is like what happens after this like big disaster happens, and what happens to the depressive symptoms for the resident within the counties which were like affected. So we have some work on that, but I wanted to like definitely look into more into that, and obviously thank you for giving some suggestions here. The second question is about how people are using this for like more into like business domain, and how as a academic professor as well as somebody who's interested in business can bring my research background to this entrepreneurial idea using this data. That's what I wanted to ask as well. Thank you so much.
Yeah. Well, I think the 4 case studies, of the 4, 3 are all entrepreneurial. 2 are. Enveris began as a startup between 2 PhD students that basically used their PhD project to incorporate her data for energy traders. And Circle Solutions was literally a startup by 2 students that got acquired. M3 Works also similarly began as a startup, although they weren't students, they were professionals who understood what the problem statement was. There's an entire climate tech burgeoning industry that we find pretty regularly. The way we discover them is when they reach out to us with an issue because of lack of some barrier in the access. But the sectors that come to mind that I want to highlight that we see a lot of traction in for entrepreneurial innovation, climate tech for mitigation, agriculture or precision agriculture. So helping farmers via their phone know exactly when to spray, when to put in disease protection. There's a lot going on in terms of looking at weather data with soil moisture data. You want to optimize irrigation and crop yield and things like that. So there's tools that farmers need literally as they're on the tractor. Renewable energy, which we talked about, climate resilience solutions. So looking at how can we understand climate risk associated with flood risk? How do we help support urban planners? And the most interesting one recently that's pretty much in my daily conversation is wildfire risk assessment. So understanding and using AI models for short-term 3 to 7 day to 1 month to 3 month outlooks on wildfires. So the time horizon is the challenge here. How can we integrate based on laws of physics with the state of the knowledge prediction that is in the decision timescale? So we're good at long-term, prediction and projection, but it's this interannual time period where we want to make near real-time decisions. Once you're in the 7-day window, it's a different problem statement. But the 7-day to 2 months to 3 months is the opportunity. So there's a lot of AI solution and weather forecasting. There's a lot going on in the weather forecasting space. And our cloud partners actually have published a lot of papers, and you may have heard about GraphCast and other tools that are launched by Google, Tomorrow AI, so on and so forth. I think it's cloud access to NOAA data because of its scalability is one of the many features for attraction.
Thank you so much. Is there any related with the health, any kind of like innovative project that's related with the health? If you just have in mind.
Yes, there is one, and I actually have their app downloaded, and it's allergy and asthma. If I find the app on my phone, I'll put it here. It's unclear if they're accessing and processing the data via the cloud, but that's an example of an app that's a startup, essentially. Oh goodness, it starts with A, and I use it all the time. I think there are more conversations on the health space, and that may be a good follow-up with Jen Runkle.
I would just add to that. I put the point of contact at WVU is Joshua Meadows. I put his email address in the chat. Also, both Deirdre and Lauren, who are on the call as well, could follow up with you. I think that there was some interest at WVU Medicine about some related projects for fellows activities that we can try to dig into that and get you more information, but that could be a nice connection point for you.
No, I was.
Thank you so much.
My apologies. I was just going to say that Kate does a search on articles and that sort of thing written using this data. So Kate, do we have any listed like that?
There's one that I know of off the top of my head that I'll drop in the chat. It's related to using GHCN in relation to tick-borne illnesses and how increasing temperatures can relate to increased risk of tick-borne illnesses. So I'll drop that paper link in the chat.
Would you like to explain what you're doing? Because I did such a bad job of it.
Oh,
Thank you.
No worries. Definitely happy to chat about it. So what I'm doing is we were curious just about publications that are using the data that we're making available through the program. So I'll do a Google Scholar search or a Web of Science search, and use keywords. So any of the data sets that we're hosting, I'll use those as keywords, our cloud service providers, and just NOAA itself. And I'll see what publications come up and then just verify that it's using the data. And this way it just helps us get an understanding of how the data is being used, the unique use cases. It's always really interesting to see the benefits that are coming from sharing this data publicly. And what's always very interesting is just seeing the wide range of research that's being done. So the different focus areas, but also just it's being used globally. That's always exciting to see too.
And will you just say for a minute what some of the talk a little bit about the limitations?
Sure, definitely. So it's challenging, and I'm sure just being in the research space, people aware of this too, but every publication will ask you to cite in a different way. So it's become more common for research publications to have a data availability statement. So at the bottom, if you're accessing public data, they'll ask you to put that blurb at the bottom that says, hey, I've accessed GHCN and I accessed it via AWS on the specific date. Not all publications will ask people to specifically list it. Maybe they'll say, I access GHCN, and they'll just cite NOAA in general, but they won't say specifically where they accessed it from. So sometimes it's a challenge just to see exactly how people have accessed the data, but knowing that is helpful to us just to help show the value that having these various access points provide. But yeah, it is a challenge just to figure that out sometimes. Thanks, Adrian.
Yeah, thank you, Kate. I just, to the point here is just that we don't think we're capturing everything just yet, you know, because it's still kind of new. So we think there's more out there than we're aware of, but we'll leave it at that. I see there's another question.
Yeah, Billy? You're muted. You should be able to unmute there, Billy, if you. And let me, while Billy's doing that, let me just say that anyone who may be interested in exploring a potential fellow type project, reach out to Deirdre, and we would be happy to brainstorm with you and to, you know, help you explore it, look at some other things that are happening and help you create some kind of fellow activity.
You know, another one that comes to mind is Fitbit. Many of us are familiar with Fitbit, and Fitbit is providing more and more. It's wearable tech, health tech, but it can grow beyond in terms of serving as a sensor to collect your specific observations and then send it to the cloud and then kind of compare environmental stressors. Like if you're expecting to have 95 degrees at 3 p.m. and you're out for a run and you need to know how that's going to affect you, it can give you a predictive indicator. So I put one called Daily Breath here in the chat, but Fitbit comes to mind. Now it's a, you know, health tech is so specific and so nuanced in terms of all the things they have to go through and the, you know, the, what do they call it? Like you have to be clear for HIPAA violation and clarity and that kind of, you know, medical information is tricky,
Right.
but there's a lot of demand for health tech.
Billy, I see you're unmuted.
Yeah, sorry, it took a little while for it to show up as not being grayed out. Yeah, I guess my question is thinking about how long you're typically storing data for, and it might vary by different products. But like for high resolution weather model data, like for example, you know, if we wanted to go back to Hurricane Helene or you know, go back further to Hurricane Florence and look at like what was the distribution of precipitation during past storm events, is that typically something where you know, the high spatial and temporal resolution data, does it get pulled after some period in the past? Like, is it just the last 5 years, or is it everything is up there?
Adrian, you want me to take that?
Please.
Yep. In general, we appreciate and really understand that, you know, researchers and startups want period of record. So where possible, period of record is sort of the motivation. However, that has to be balanced by a couple of things. So satellite data and period of record for satellite data has been our recent huge ask, and we're working through it. But that also means a lot of getting access into the, you know, the the system source and getting it straight into the cloud. So for station data, we go back as far as possible, and generally for the period of record. But for satellite data, we have 16, 17, 18, and 19 will be up. Radar data have to go back, but in all of our websites, it gives you the information in terms of how far back we go. That being said, we always have users wanting more, or finding that while we may have thought we got as far as back as possible, there's still a demand. So in general, I guess it's really dependent on the application context. And more, thanks. And Jack here put in the chat that for her data, it goes back to 2014. And each data set has its own sort of story and journey, because it originates from a science academic team, and then there's an operation dimension to that data set. So it's not all perfect, but I guess the question is, how far back is your case study looking? If there's something that you want and you don't see it, please email us at NODD.
Yes.
Yeah.
Cool, thank you.
That was a great answer, Jenny. I really appreciate it. It is very complicated. And I just want to reiterate what Jenny just said. If you don't see what you want after checking out the list of data on the website, reach out to us and talk it through with us. We'll see what we can do.
I think we had another question from Nabila, if I pronounced that correctly.
Yes. Nabila.
Oh,
Hello, everyone. Thank you so much for introducing this to us. And everyone.
a little bit of an echo, but we can hear you.
I'm sorry.
It's okay.
All right.
Okay. Okay. Other questions? Like I said, we're very interested in working with anybody who has an interest in being a fellow or exploring the possibility of incorporating the climate and weather data into a course that you may be teaching or will be teaching, and just working with you.
Yeah, James, I'm interested to about that fellow. I'm already a research fellow at WVU.
Okay.
So I'm in New Regulatory Center there. We basically study regulation related with the health. I was also in the Regional Research Institute there as well in WVU, which is below the Health Science building there. But yeah, so can you tell me more about it, and how can we work around this the cloud analytics fellowship?
You're muted, Adrian.
My apologies. Could you repeat your question for me, please?
Yeah. So how can we get this access to fellowship, or what's the process for that?
I think that one's yours, Jim.
Yeah, so we're working with both App State and RIEEE to help them set up a fellows program. So whoever at your institution, if you coordinate with that person, I mean, they be careful, they may nominate you to be the official point of contact, which would be fine. So we would work with you to set that up, explain how and we'd basically just share with you what we've done at WVU. As I said, they've been kind of our case study, our guinea pig, if you will, but we've worked out a lot of the bugs and it's going very well. And so, as I said earlier, Joshua has done a great job getting it really starting to hit on all cylinders. So we could talk that through with you. And as I said, just Deidre is the perfect point of contact for that.
Well, thank you so much. I'll ask our friend Lauren here. She must be in this meeting as well. Thank you so much. Appreciate that.
And I think that probably answers your question too, Nabila, right? Yeah. All right. And then we have one thing that would be great for teaching purposes would be example case studies with detailed walkthroughs. Is that something fellows could work on? You mean, I assume that is asking about student work, student case studies in particular?
Yeah,
Josh?
so if I'm teaching a course on, atmospheric chemistry and I want to use aerosol optical depth data, is there like already a canned walkthrough and case study that we could use in class?
Maybe we could
It
certainly.
varies.
Go ahead, Jenny.
Oh yeah, sorry. Aerosol optical depth is a meteorological parameter, and I love that you referenced it. So oftentimes, the meteorological and climatological parameters have a value-added product that gets built onto the raw observations. We have, in many cases, you have direct-to-direct case study, so that's great. It's not always accessible. The observation, for example, like ABI imagery coming off a satellite, I'm sure there's examples of direct applications, but generally speaking, a lot of them have to get kind of down the curve in product development into a useful format that startups and other companies start to use. Each data set has its own value chain, and then you multiply that value chain across all sectors, economic and others. So I think, the case studies that we reflected here are just a subset of a few more where we've been able to trace the integration. In many cases, the meteorological and climatological parameters go into an equation that produces some prediction or goes into an AI model or an ML model. So I think it's, I might kind of think about encouraging the students, what environmental stressor or opportunity are they interested in solving? What kind of motivates them, and sort of work upstream to the problem and source the data that integrates into that value chain. But there's many ways to look at this. Short answer is yes and no, and not always.
I'll just draw people's attention to Billy's response as well. He's dropped in a link to a landing page on AWS, which is a NOAA CONUS data set. And if you scroll down to the bottom, you'll see that there are tutorials and publications and other kinds of support activities. Thank you, Billy, for doing that. They don't all have it. It will depend. It will vary based on data set, as Jenny is describing.
Yeah, and it reminded me, then we can also point to the Planetary Computer, which is via Microsoft, and they have some great examples of case studies.
Yeah, and it's a great question because, part of the fellows program, it's brand new. And so we want to develop these things for others to use. And so, working with folks like you to step up and help us develop these things, then others can use them. And it just helps grow the momentum of the whole program. So it's a great question.
Yeah, Billy, I see you're, I'm looking at that. We'll have to look at that, but we're working with Google. They're giving us new access, but previously Google required they did certain of the uploading, that kind of thing themselves. We're taking on more of that. So hopefully we'll resolve some of these things. But I've made note of it, so we'll follow up on that. Thank you for highlighting that.
I see that as version 3, and then there's a version 4 that they're making available. But that could be it.
Yeah, I'm sure you're right. So, and I will say for folks, as you're working to set up your Cloud Data Analytics Fellows programs, and you're looking at NOAA data, you don't have to have that thing all set up to ask us questions. You can reach us at the nod@noaa.gov. And we will answer any questions you have.
If I could just, this is Billy again, I'll use that I can unmute. So I guess maybe underlying some of these questions, like funding for this, that would be something that's done internally. Like Appalachian would need to put together a cloud like cloud computing fellowship thing. If we were going to say develop course material, and we're looking for like whatever, a teaching release or some summer salary or something to develop course material, that would be done through Appalachian, not through this bigger. There's no like pot of money that we can apply for these fellowships through with this group. Is that
We've
right?
submitted a proposal to the Appalachian Regional Commission that we literally hope to hear from any day now, that would provide some funding to do the things you're talking about. And so hopefully if that comes through, then we will have some, not a lot, but enough to help with some of those things. And so we're doing that in partnership with, you know, Appalachian State and RIEEE and WPU.
That sounds awesome. And then I guess the other question I would have is there like a point of contact at West Virginia University who, like for doing sort of lessons learned, if there was someone we wanted to contact?
Joshua Meadows.
Okay, thanks.
I put his email in the chat. Also, Deirdre on this call, she's our primary point of contact for everybody to coordinate.
Thank you.
If I can real quick, this is Deirdre. If we have enough interest, I can create a meeting and we can have Joshua attend that meeting and go through lessons learned. We can go through the projects that they've completed already. And so he can give you all of that insight at that time.
And that's something that I really want to encourage. I hope that all of the institutions that set up fellows programs are in constant communication and coordinating, and just a constant feedback of how can we do this better? How can we grow it? How can we expand it? Okay, so are there any other questions? If not, please let me thank everyone for being here today. Grace, I'd like to turn it back over to you for closing.
Oh, Jenny has her hand up. Can she?
Oh, I'm sorry, Jenny. Go ahead.
So I certainly don't want the last word. However, I do want to mention real quickly, it's really important for NOAA team and the NODD team here that as you progress down this journey and come up with case studies and integration points, NOAA and the NODD team are very, very interested in both your experience and any potential outcomes, because this is just half the journey. The other half, as some of the listeners are on this call, really, these case studies are critical in developing the value of the data. So the economic quantification methods that are used to value the data comes through in the decision context that gets improved, or the development of a climate tech that has evaluation. So that helps us in many ways. And then also it just really helps us understand, you know, format, latency, some of the technical dimensions of the data that you have experience with. So thanks, but I don't want the last word.
That's okay. I'm going to jump in here and I'm going to say, I want to thank Jim in particular. And I'm really excited about the proposal to the Regional Commission. That's really exciting, and I got my fingers crossed for you. I'm so pleased by this program and so pleased to be a part of it, and really looking forward to working with the rest of you as well. I know that Grace had to drop off, but Lauren may be on, and Lauren might want to say a word.
Okay, absolutely.
Oh no.
If not, that's okay.
No, I don't. We can't hear you, Lauren. Yeah. I don't think her mic is working. Yeah, it's okay.
Maybe
I've forgotten that from earlier too. Okay. Well,
yep. All right.
I guess gives you the last word, Jim.
Well, let me thank Lauren. Let me thank Grace and everybody who's been on. It's been a fantastic discussion. Adrian, Jenny, thank you as always. Amazing information. The case studies are fantastic. So thanks everybody again for follow up. You know, Lauren, she just sent us a great note there, and Deirdre just follow up, and we're excited to work with you guys. So With that, thanks again, and I hope everybody has a wonderful day.